Welcome back to our channel Mathemagix JEE. In today's video, we are going to discuss some useful identities which are commonly overlooked by us during our preparation. These identities are used throughout all the chapters of 11th and 12th mathematics. I hope this video will remind you about this type of identities and special cases which we have to take care of while solving problems. If you are new to our channel, subscribe to our channel for more such videos related to JEE preparation. Let us jump to our discussion. So the very first identity we have is this identity. Okay, so this identity we all know from previous classes, right? From ninth or 10th we know this identity, but this identity is not used that much during that time. Okay, but in many JEE problems we encounter such type of situations where we will use this identity to solve a given problem. More specifically, this important result that is derived from this identity is very much useful. Okay, that if we have three numbers a, b and c and sum of their cubes is three times their product, we have two possibilities. Okay, either a plus b plus c, which is the sum of all the three numbers, that is 0, or the other case which we have is the numbers are all equal. That means either one of them must be true. Let us see its application in detail in a problem. Okay, so in this problem we have a trigonometric setup. Okay, we are given this set S equal to, this S contains all the elements x belonging to open 0 to open 2 pi, such that sine cube x minus 2 root 2 cos cube x plus 3 by 2 times root 2 sine 2x plus 1 equal to 0. Okay, then find summation x belongs to S tan square x by 2. That means we have a equation here and x is a root of this equation. Okay, that means x is belonging to the set S, right? S contains all the roots of this equation. Then we have to calculate this summation. That means for each x we have in this set, we have to calculate tan square x by 2 and sum all those tan square terms. Okay, so our first idea here will be to find somehow this x. Okay, or maybe we can find an expression for tan x by 2, but here this equation is a bit messy. We can see here this is power 3, this is power 3, right? So working with this equation becomes a little bit hectic, so we have to somehow try to simplify our calculations. To do this, we can see here this thing we can write as sin x whole cube, right? And this thing we can write as root 2 cos x this whole cube, right? And this thing can also be simplified as 3 by 2 times root 2 times 2 sin x cos x, right? Then we get it is equal to 3 root 2 sin x cos x, right? Now for some time, if I call this sin x equal to some a and root 2 cos x to be some b and this 1 to be some c, okay, then this is nothing but a cube minus b cube plus c cube, right? And we are interested to create this form. Okay, a cube plus b cube plus c cube minus 3abc equal to 0. So first of all, we have to have plus sign here, right? So we have to include this minus sign here, so that minus 1 whole cube will become minus 1. So minus sign will come here. So we assume this a to be our sin x, b to be our minus root 2 times cos x, okay, and this c to be our 1. So this thing becomes minus 3abc. I hope you can understand how we manipulated the terms. Okay, now we have this equation a cube plus b cube plus c cube minus 3abc equal to 0, right? From this equation, so we can say we have two possibilities here, a plus b plus c equal to 0 or a equal to b equal to c, right? That means if we check the conditions independently, we get a equal to b equal to c gives us sin x equal to minus root 2 cos x equal to 1, right? And a plus b plus c equal to 0 gives us sin x minus root 2 cos x plus 1 equal to 0. Now we can clearly see this thing is not possible. Why? Because if I take, let's say, this equality here, this sin x equal to 1, okay, then we have x equal to, let's say, pi by 2, okay, x is pi by 2. But then if x is pi by 2, this thing is not going to happen, okay, because this will be 0 and 0 is not equal to 1. That means for any possible value of x, we don't have these three things equal to each other. So this case is omitted. This case is not possible, okay. So we have to work only on this case. So that is how we can use this identity to simplify this cubic equation into a linear equation here in terms of sine and cos. Okay. Now our motive is to find this tan square x by 2. Okay. Or specifically tan x by 2. So that we can find all the sum of tan square x by 2, where x is the root of this equation. Okay. That means we can express this sine x and cos x in terms of tan x by 2. That means we can write this sine x equal to 2 tan x by 2 divided by 1 plus tan square x by 2. Okay. So let's call this tan x by 2 equal to some t. Okay. So this will be 2t divided by 1 plus t square, right? And cos x will be 1 minus t square divided by 1 plus t square. From here we get this will be 2t minus root 2 plus root 2t square plus 1 plus t square equal to 0. Okay. So we can see this is a quadratic equation in t, right? So this quadratic equation is t square times 1 plus root 2 plus 2t minus root 2 plus 1. So this thing we can write as minus of root 2 minus 1 equal to 0. So if we check the discriminant of this quadratic equation, we get d equal to 4, then plus 4 times 1. Okay. The product of these two is 1. So this will be 8. So d is positive. That means we have two distinct real roots of this equation, two distinct possible values of tan x by 2. Okay. So we have to simplify this thing. T1 square plus T2 square. T1 and T2 are what? T1 and T2 are the roots of this equation, right? So this thing we can find easily by using the relation between roots and coefficients. This will be nothing but T1 plus T2 whole square minus 2 T1 T2. Okay. And T1 plus T2 is what? It will be minus 2 divided by root 2 plus 1, right? So this thing, summation tan square x by 2, where x belongs to the set S, this thing is equal to 4 divided by root 2 plus 1 whole square minus 2 times T1 T2. T1 T2 is what? This will be root 2 minus 1 divided by root 2 plus 1 with a negative sign. So this will be plus here times this root 2 minus 1 divided by root 2 plus 1. Okay. So this thing we can simplify easily. This will be whole square plus 2 times. This will be root 2 minus 1 whole square. And this thing, if we calculate, this will be 6 times root 2 minus 1 whole square is how much? 2 plus 1 minus 2 root 2, right? That means 3 minus 2 root 2. So this thing comes out to be 18 minus 12 root 2. This is our answer. Okay. So you can see how such identities are useful in solving some part of a given equation. Okay. And this case, a equal to b equal to c, this case is not possible here, but in any other equation it may be possible. In that case, what we have to do is just take the union of both the cases. Okay. Because we have a or condition here. We are saying this or this. Okay. So the next identity we have here, this is related to factorization. Okay. So we have these two scenarios here. A to the power n plus b to the power n is a plus b times this thing. Okay. You can check this by vanishing method. Suppose if you put, let's say, b equal to minus a in this expression. Okay. Then this expression will definitely be equal to 0 because n is an odd integer here, right? That means b minus minus a, which is b plus a, will definitely be a factor of this expression. Okay. Then we can generate the rest of the expression here. And similarly, we can prove this using the same method. Okay. Now here comes the important part, okay, important result, which is necessary sometimes to solve some specific problems, okay. So if n is an odd integer, a to the power n plus b to the power n is divisible by a plus b, okay. And then we have, for all n, a to the power n minus b to the power n is divisible by a minus b. That's it, okay. This thing you need to note down. We can find its application in remainder problems in binomial theorem chapter, and I have brought a similar type of question for practice, okay. So this is the question we have. Here it says 3479 whole to the power 2026 minus 1451 times 1452 to the power 2025 plus 575 to the power 2025 is divisible by which of the following numbers, okay. So this is a single choice question, only one option is correct. Now what will be our approach to solve this problem, okay, using the concept that we just discussed. So we can see here an interesting pattern, okay. This power is 2026, right? But this power and this power are 2025. That means we have to express this expression in two parts, okay. One part will contain the power 2026 and other part will contain the power 2025, like this, okay. A to the power n plus b to the power n, or a to the power n minus b to the power n. That is our main motive. Now how to do this? Well, we can see here this 1451 we can write as 1452 minus 1, right? That means we can take 1452 with this, so that it becomes 1452 to the power 2026, and the remaining part, this minus and minus will become plus, right? So this will be plus 1452 to the power 2025. So we can do this manipulation here, okay. So let us do this. That means we get 3479 to the power 2026, then we get plus 1452 to the power 2025 minus 1452 to the power 2026 plus 575, then whole to the power 2025, right? Now what we have to do next, we have to club these terms, okay, because they contain the same power 2026 and 2026. So we can club this. That means if we call this, let's say, a to the power n here, okay, this is nothing but b to the power n, right? And also we can club this too. So this becomes small a to the power capital N, and this becomes small b to the power capital N, okay. That means this will be a to the power n minus b to the power n, and a minus b is what? A minus b, if we calculate, this will become 3479 minus 1452. That means this becomes 7 2, then 20, okay. That means 2027. That means these two terms, or we can say the sum of these two terms here, this to the power 2026 and minus 1452 to the power 2026, okay, the sum of these two terms is divisible by 2027, right? Now if we check these two terms here, 1452 and 575, that means 1452 and we have here 575, that means their sum is 7, then 2, then 2027, okay. That means we have also in this case a plus b equal to 2027, right? And also we can see the exponents are odd in this case, okay. Here capital N is odd. That means we can use this result, that a to the power n plus b to the power n is divisible by a plus b if this n is an odd integer, okay. So we can say the whole expression will be divisible by 2027. So what will be our correct option here? Option C will be our correct option, okay. Now this is the third and final point we have in this session, okay. Some important factorizations. Here I have listed three factorizations, but the idea which is used to prove these identities can be extended to n number of identities, okay. What is the purpose behind this type of factorizations? This type of factorizations we mainly encounter in sequence and series chapter, where we have to find the telescopic sum, okay. And why do we have a telescopy here? Let's discuss. So this term is definitely less than this, right? That means if we call this t of r here, this you can verify, it will be t of r plus 1. Okay, or maybe we can use x here, t of x, this will be surely t of x plus 1. So this is the idea behind this factorization. Similarly here you can also verify, this will be t of x plus 1 and this will be t of x. Okay, similarly for this we have this as t of x plus 1 and this will be t of x. So these things are generally used in telescopic summations. Now the question is how to prove them. Okay, so the idea behind them is basically completing the square. So if we try to complete the square here, this will be x to the power 4 minus 2x square plus 1. Okay, this thing simplifies to x square minus 1 whole square, and then we have a minus x square here, right? So this thing becomes x square minus 1 whole square minus x whole square, right? So this thing we can write by using the formula of a square minus b square equal to a minus b into a plus b. We can write this as x square plus x minus 1 times x square minus x minus 1. Okay, and similarly we can say this will be x to the power 4 plus this will be 2x square. Okay, and then plus 1, and as we added a x square here, we have to subtract this. That means it becomes x square plus 1 whole square minus x whole square. Okay, and similarly you can expand this into this factors, right? And for this also we have similar concept, 4x to the power 4 plus 1, and we have to add a 4x here, right? This thing is 2x whole square, sorry, 2x square whole square, and this is 1 square. That means we have to add here a plus 4x square. That's it. Okay, and as we are adding this extra term, we have to subtract this. That means minus 4x square. Okay, so this thing becomes 2x square plus 1 whole square, and this thing becomes 2x whole square, right? Then you can proceed using the formula and you will get the desired factors. Now let us discuss what will be the use of these factorizations in telescopic summations. Okay, so here we have a problem, summation r cube divided by r to the power 8 minus 2 r to the power 6 minus r to the power 4 minus 2 r square plus 1. Okay, so we have this summation from r equal to 1 to n. Now in this question, this denominator here is very special. Okay, this type of expressions frequently occur in JEE questions. We have to somehow factorize this, right? Because the main idea of telescopic series is to factor out the expressions in the denominator. So somehow we have to factor this. But how to factor this type of expressions? See, here we have a pattern. Okay, here this power is 8, here this is 6, here this is 4, this is 2, this is 0, right? That means the power drops by an amount of 2 in each term, right? Also, there is some symmetry between the coefficients of each term. Okay, so here it is coefficient plus 1, it is minus 2, it is minus 1, this is the middle. Okay, and about this middle line we have symmetric coefficients. Okay, so we have here minus 2, here we have again plus 1, right? This is the middle line. About this we have symmetric coefficients. So the main idea behind this type of factorizations is to divide by this middle term. Okay, this middle term means that we have to divide this expression by r to the power 4. Okay, not minus r to the power 4, we have to simply divide it by r to the power 4. That's it. So let's divide this. So we get this thing here, it will be r cube divided by, this will be r to the power 4, right? This will be r to the power 4 minus 2r square minus 1 minus 2 by r square. Okay, plus 1 by r to the power 4. Now observe a thing here, that we can actually simplify this term inside this bracket in terms of r square plus 1 by r square. How? If we club these two terms here, we get, this will be minus 2 times r square plus 1 by r square. Okay, and we have minus 1 here, and then we have plus r to the power 4 plus 1 by r to the power 4. And this thing we can also write in terms of r square plus 1 by r square, right? This will be r square plus 1 by r square whole square plus minus 2, right? That means we get simply r square plus 1 by r square, this whole square. Then we have this minus 2 times r square plus 1 by r square minus 3, right? So we can call this expression some x square minus 2x minus 3, right? And we can factorize this. This will be x minus 3 times x plus 1, right? So this thing actually simplifies to r cube divided by r to the power 4 as it is. And then we have x minus 3. That means x is r square plus 1 by r square. So r square plus 1 by r square minus 3. Okay. And then we have r square plus 1 by r square plus 1. Okay. And then we have to simplify this denominator. If we simplify this, this will become r cube divided by r to the power 4 minus 3r square plus 1 times r to the power 4 plus r square plus 1. Okay, like this. So this is the factorization process of the denominator. Now if we proceed with our question, it is, we can write it is equal to summation r cube divided by r to the power 4 minus 3r square plus 1 times r to the power 4 plus r square plus 1, right? So we can write this thing telescopically. Okay, so we can write this thing in terms of difference of two terms so that we get these things separated out. Okay, that is our main motive. So we can write this r cube as r times r square, right? And then if we check the difference of these two terms, we get difference of these two terms r to the power 4 minus 3r square plus 1. Let's keep it in the right hand side, and in the left hand side we have r to the power 4 plus r square plus 1. Okay, so if we subtract them, we get 4r square. That means we need a 4 here, right? So we can multiply and divide by 4. So this will be 1 by 4 times summation r equal to 1 to n, then r times this 4r square we can write as the difference of these two terms, right? R to the power 4 plus r square plus 1 minus r to the power 4 minus 3r square plus 1 divided by the product of these two terms. Okay, so we can split these two terms, r equal to 1 to n, then we have r here, and then we have 1 by r to the power 4 minus 3r square plus 1 minus we have 1 by r to the power 4 plus r square plus 1. So this will be, if we split the sigma, 1 by 4 summation r equal to 1 to n, this will be r divided by r to the power 4 minus 3r square plus 1 minus summation r equal to 1 to n, then we have r divided by r to the power 4 plus r square plus 1. Okay, and 1 by 4 outside. So we have to basically calculate this two sigmas. That's it. Now how to calculate this? We can again use the concept of splitting this summation into two telescopic terms, right? Because we know the factorization of this expression. The factorization is r square plus r minus 1 times r square minus r minus 1. Okay, so r square plus r minus 1 and then r square minus r minus 1, right? And this thing also in two terms, two factors. Okay, r square plus 1 plus r, and we have r square minus r minus plus 1. Okay, like this. And if we check the difference of this two terms here, this will be 2r, right? This minus this becomes 2r, so we have to multiply and divide by 2 here. That means we get from here 1 by 4 times 1 by 2 times summation r equal to 1 to n, this will be 2r. So 2r is basically this minus this, that means r square plus r minus 1 minus r square minus r minus 1, right? Divided by the product of these two terms. Okay, and then we have similarly this term here, r square plus 1 plus r minus r square minus r plus 1 is again 2r, so we have to multiply and divide by 2 here. That means 1 by 4 times 1 by 2 times summation r equal to 1 to n. Then we have r square, then we have plus r plus 1 minus r square minus r plus 1, okay, divided by the product of these two terms. Now the rest is simply calculation by telescopic approach. So this will be 1 by 8 outside the whole expression. Then we have r equal to 1 to n summation 1 divided by r square minus r minus 1 minus 1 divided by r square plus r plus 1, sorry, minus 1. And then we have minus summation r equal to 1 to n 1 divided by, this will be r square minus r plus 1 minus 1 by r square plus r plus 1, okay, like this. Now rest of the work is very simple. This thing is nothing but t of r plus 1, right? This thing is t of r, and this is t of r, this is t of r plus 1, okay. Let's call this t dash. So just by using telescopic approach you can cancel the terms and write the answer in terms of n, okay. The rest of the part I am leaving for you, the calculation part. So this was the concept that we used, okay. This factorizations are pretty much useful in solving this type of telescopic sums. So that's it guys for this session. This question you can try and post in the comments. This is also based on the telescopic summation, okay. And the last identity that we saw will be used here to find the sum of this series. Do let me know in the comments if you have any doubts, and please give your valuable feedback about which type of content would you prefer. In upcoming sessions I am planning to take some specific subtopics from all the chapters that are frequently asked in JEE, and we will also solve problems based on them, standard problems that are generally expected in the exam. For example, I was thinking about taking geometry of complex numbers as our next discussion topic. So please let me know in the comments which subtopic should I choose for the next video. I hope these videos will definitely boost your preparation.